All right, 6.5, we're going to look at more division with radicals. In 6.4, we had some radicals on the bottom of our fractions, but when we simplify, those radicals always went away. And that is not always the case. So we want to look today at what happens when they don't go away. And one of the main things is we don't want radicals on the bottom of our fractions. So we want to see how to make them go away, essentially. Okay? So we're going to hop right into the examples here. And we're going to do what's called rationalize the denominator. Okay? So essentially that just means I want to get the radical off the bottom of the fraction. I want to make sure that we have just numbers down there and no square roots on those pieces. Okay, so we want to look here and how we're going to do that. So let's get into this first example and see what's going on. So 2 times the square root of 3 over 7 times the square root of 5. Now, with any radical, we always look to see if we can simplify the radical first. But in this case, we have square root of 3, square root of 5. As both prime, we cannot simplify them or take those square roots. And so we need to be able to get that square root of 5 where it no longer has a square root anymore. Okay, and so let's begin to dive into that. Now, we're not going to worry about any of the other pieces. We're going to look at just that square root of 5 on the bottom. Okay. Now, we want to remember that our index here is a 2 and that our power is a 1. Now, to get that square root off, we really need those things to match. We need that power on this 5 to be a 2 so that it'll cancel with us. And to do that, what we're going to do is we're going to multiply here on the bottom by a square root of 5. Now, we only need 1 because this is a 1, and to get to 2, you need 1 more. You do as many as it takes to get up to that index. So if it was a root of 3, I would need 2 5s and go from there. Okay, now you'll see some examples of that later. And as always, what I do to the bottom of the fraction, I must do to the top of the fraction. Okay. All right, so here, when we multiply this, we get 2 on the top, and then square root 3 times 5 is 15, just as we looked at previously. And then on the bottom, we have our 7. If I do square root of 5 times the square root of 5, we know that from last time, when we take the square root times the square root of the same thing, it's what's inside, right? And so that just becomes times 5. Notice the square root's gone for those. And that's because we now have 5 squared, and then the square and the square root cancel out. Well, we look to reduce, it doesn't. And so we multiply the bottom together. So we get 2 square root of 15 over 35. And that is our results. Okay. And so we want to look for those pieces and be able to break them down that way. All right, let's try another one here. Let's say we have square root of 3x over 20. Okay, this one's going to have a couple more steps to it because we always got to break things down first. That way it makes our lives a little easier. Okay, but the first piece, anytime that we have those, we want to first separate it. Okay, so first step, square root of 3x over square root of 20. Now I do want to simplify those radicals if I can. It's going to make my life easier later on. And so if we can do that, let's do that, all right? And so 20, we can actually break that down. That's going to be 4 times 5. And so we're going to get that to be 2 square root of 5 because that 4 comes out, remember? So I'm going to do those things a little faster now. I'm not going to show every step. You need to break that piece down to the side and then write it in. Or if you want to break it down within the problem, that's okay with those. But I'm going to assume that we know how to simplify at this point. Well, square root of 3x, 3 is prime, x doesn't have a power, so it stays square root of 3x. Now we can see we have that square root of 5 again, so we're going to need to multiply by square root of 5. Right, and so we get top 15x over 2 times 5, which means finally we're going to get square root of 15x over 10. Now, those do not reduce because that 15 is inside the radical and that 10 is not. So be careful with that. Don't try to reduce things that are in different places. Now, if it was on the outside, we could reduce those. But in this case, it's on the inside. So we cannot reduce that, right? All right, number 3. Let's do a third root now. 16 over 9. Okay. Now, again, if we can, I do want to reduce these things. Okay, I want to simplify, break them apart, simplify. So I'm going to do that here. I'm first just going to break it apart. Third root for those. All right, let's look at 16. 16 for a third root is 8 and 2. And so that means that we can break this into 2, third root of 2. Right? So we're going to break that thing down early on there with that. Okay. Now on the bottom, 9 does not break down. That's a perfect square, but it's not a perfect third. There's no perfect third with it. But we are going to use a little trick. Okay. Now, if you don't do this, you're just going to get some bigger numbers. You have to reduce again later. So this is why I like to do it this way. So I use the smallest amounts for it. Okay. I want to represent 9 because 9 is a perfect square, or it's something to a power. 9 is 3 squared. Okay. Now, again, the reason why I want to do that is it means I have to multiply by less things. All right. If I leave the 9, I'm going to have to multiply by cube root of 9 squared to get up to the right number of powers with that. But in this case, because I did 3 squared, I already have 2 3s. I only need 1 more 3 to get up to that root. And so I'm going to multiply here the third root of 3. Because now I've got 2 3 3s, okay, for those. And it's going to cancel those roots out for me. All right, so on top, I got a 2, third root, 2 times 3 is 6. And then on the bottom, the third roots and the 3 powers are going to cancel. I'm left with what's inside, which is 3. None of that reduces the third roots. And so we're complete on that problem. Okay. Now, let's kind of look at that problem. What if I've done that without reducing it? So I'm going to kind of change modes here for just a second. And I'm going to do the same problem over here, but I'm going to leave this at this place. So I'm going to do this in blue so that you can see the difference and see what you would have had done had you not broken down that 9. Okay. All right. So we still would have broken down the 16. That would have given me the third 2 times the third root of 2 over the third root of 9. 9 is a 1 power, so to make these match, I need 2 more. So I would have done this as the third root of 9 squared. Okay, so now you can see I have 2 3 on the power, so that's going to reduce for me. So now on top, we do 2 third root, 2 times 9 squared. 9 squared is 81. Multiply that by 2, and we're going to get 162 over 9. Okay. Well, 162, we're looking at third roots. Is a little bit harder. We got to think through our list, but we'll find that 27 does work. 27 times 6 is what's going to give me that 162. And so we would get 2 times 3, because the third root of 27 is 3, third root of 6 over 9. Well, the 3 and the 9 reduce to 1 and 3. And so that still gives me 2, third root of 6 over 3. So I still get the same answer, but we've got much bigger numbers that we have to work with and break down. So that's why I try to make sure I break that thing down at the beginning. You saw how much easier it was to work with 3 squared because there was less reduction there, less simplification. But if I don't, I can still do it, but I've got to break down bigger numbers. So we have to be careful with that on those pieces and think through those processes. Okay. All right, number 4. Cube root of 3a over cube root of 5c. Right. So again, we want to look at those powers. Now in this case, 3a, 5c, none of those are perfect cubes. It's not going to break down. So I'm going to look here, my power is on the bottom. So I need to get to 3. I've got one of each of those. So I need 2 more. So I need a cube root of 5 squared and a c squared. Because I get both of those things up to a 3. So cube root of 5 squared c squared. Okay. So now we need to multiply. So on top, we're going to get a cube root. Well, 5 squared is 25 times 3 is 75. And then we have our letters, and they don't go together because they're 2 different letters. And then on the bottom, now that we have all matching powers, because there are 3 5s and 3 2s, they cancel with the root, and we just get 5c. Now, if we try to break down 75 for a cube root, we don't find anything. Nothing that's going to go into that. And so this is our answer. Okay. All right. Let's say we have cube root of 2y to the 4th, cube root of 6x to the 4th. Now, there are a few different things we can do here on this one. And so I don't want to do too many different reduction pieces. So I'm only simplify the radicals as they are. And so that I don't get 2 things. It will simplify later on, and I'll reduce at the end of the problem to make it work for us here. Because I don't want to do a bunch of back and forth on these pieces. But there are a few different ways we can work this problem. But 2, there's no third root of 2, but for a 4th power, we can actually take a y out there. So 3 goes into 4 one time with 1 left over. And the same thing's going to happen on the bottom. And there's no third root of 6. But on my 4, 3 goes into 4 one time with 1 left over. All right, so now I've got to look at those powers. So that means I need to multiply. Remember, it's only the root, the third root of 6 squared x squared. What I do to the bottom, I have to do to the top. Okay. So on top, we've got a y, third root. 6 squared is going to be, what, 36? And then times 2 is 72. And then we're going to have x squared y. The order of those letters do not matter. And then on the bottom, we're going to have x and then 6x. So times 6x. Okay, now I'll put all those x's together in just a moment. All right, so now we need to see if we can simplify anything here for this one. We would actually see with 72 that 8 times 9 gives me 72, and 8 is a perfect cube. So I can take that 8 out as 2, and then we'll have the cube root of 9x squared y on the top. And then on the bottom, we're going to have 6x squared. This time we do have some numbers outside that we can reduce. We can see here that the 2 goes to a 1, the 6 goes to a 3. And so that gives us a final answer here of y, third root of 9x squared y over 3x squared. Okay. Now the 9 and the 3 do not reduce because the 9's in the radical. The x squared do not reduce because one of them is in the radical. Always remember, you can only reduce things that are inside both or both outside. So keep that in mind when you're looking at those pieces. 6. 4th root of 1 over 8 x to the 7th y to the 3rd. As always, you want to, I forgot to put my bar across the top. You need to break it apart so you can look at the individual pieces. So let's do that. We want to take the 4th root of 1 over the 4th root of 8x to the 7th y to the 3rd. But I do want to simplify those things if I can. Now, 8 doesn't have a perfect 4th, and no perfect 4th comes into it. But 1 is a perfect 4th, so we can get rid of that. Here, so we're going to have the 4th root. We can change 8 into 2 to the 3rd. That's going to make our lives easier, like we saw earlier. So I do want to do that. Okay. But on my x, so 4 goes into 7 one time with 3 left over, and 4 does not go into 3 for the y. So that makes my life a little bit easier then. Those are all 3s. I need them to be 4s. So I need one more of each one of those. So I need 4th root of 2x and y. So all of that times 1 is just the 4th root of 2xy. And then on the bottom, we're going to have this x and then 2xy. But we can put those x's together, so we do need to simplify that. We get the 4th root of 2xy on top. And on the bottom, we get 2x squared y as our result. Okay? So we're always looking for what's going to get us to that root. Okay. All right. Now let's change it up just a little bit. Still getting radicals off the bottom. -5 square root of 2 over square root of 7 minus the square root of 5. So now we've got 2 square roots with some addition or subtraction in the middle. Okay. All right, now this is where that concept that I briefly talked about in the multiplication comes in of conjugates. So our conjugates are when we have the exact same thing except for 1's plus, 1's minus on those binomials, right? And so that's what I want to multiply by here. So I'm going to take this bottom, square root of 7. This is minus, so I want plus square root of 5. Again, what I do to the bottom, I have to do to the top, right? Well, let's multiply there. So we're going to get -5 square root of 14 minus 5 square root of 10. And those are not going to simplify, so we don't have to worry about them. Now on the bottom, what's going to happen? We're going to use a trick. We know they're conjugates, so if we were to FOIL this out, the middle two are going to eliminate. And so here, when I do square root of 7 times square root of 7, that's 7. Positive times a negative is negative. Square root of 5 times square root of 5 is 5. You can use that trick, okay? Because we know they're conjugates and we've assigned to them that the middle two radicals have been canceled out for that, okay? So you don't even have to write them, is what I'm saying. Now, if you need to, you think, man, Mr. Jones, that math's not adding enough for me, I need to multiply this out, go for it. Just make sure that you only apply this when it is a conjugate to these pieces, okay? All right, well, the top here stays the same. At the bottom, 7 minus 5 is 2. We can't do any reducing. We have 5s on top, just that 2 on the bottom. So there is our result. All right, let's look at a couple more of these. So 6 square root of 3 over 3 square root of 2 minus square root of 5. Okay. All right, so again, we're going to multiply by the conjugate because we see what we have going on there. And that's going to be 3 square root of 2 plus square root of 5. Right? So on top this time, we're going to get 18 square root of 6 plus 6 square root of 15. None of that's going to reduce. Now, bottom, we have to be careful. When we square this first one, that's going to give me 9 times 2. So the 3 times 3 is the 9. Square root of 2 times square root of 2 is 2. Minus square root of 5 times square root of 5 is 5. Okay? So that's going to give me 18 square root of 6 plus 6 square root of 15 all over. We can do all this at once. 9 times 2 is 18. 18 minus 5 is 13. Now these don't reduce. We look at all three of these, 18, 13, and 6, and see if they reduce. They do not. So this is our result. Okay. All right, one more. 3 plus square root of 5 over square root of 2 plus square root of 5. So again here, you can see this conjugate needs to happen. So square root of 2 minus square root of 5. And so on top, we got a little bit more. We actually have to FOIL that out up here. So we're going to do 3 times square root of 2 is 3 square root of 2. 3 times negative square root of 5. 5 times, or square root of 5 times square root of 2 is square root of 10. And square root of 5 times square root of 5 is just minus 5. And then on bottom, we're going to get 2 minus 5. Okay. Well, on top, none of those are the same. We can't reduce them, so it stays, but we can reduce this. So 3 square root of 2 minus 3 square root of 5 plus square root of 10 minus 5, all divided by negative 3. Now, I don't like negatives on bottom. I expect you to move this negative to the front there, okay? Do not put it on top because you have to change all the signs if you put it on top. Put it in front of the fraction. So do negative and then draw your fraction. 3 square root of 2, 3 square root of 5, square root of 10 minus 5 over 3. Now we can't reduce because it has to be all of these for it to reduce. So keep that in mind when you're doing those pieces, all right? So those are the different ways that you're going to have to rationalize the denominator. It's going to take a bit of practice to get used to it. But once you figure it out, it'll go pretty quickly.